it. If anything I'm saying doesn't make sense, which is often, especially if you ask my wife, but then feel free just to stick your hand up and say something. Okay. I've worked for a whole load of places. I've done government, retail, manufacturing. I've been in this business for really far too long now, honestly. And briefly, I was one of those contractors your mum used to warn you about. These days, I work for Muller Dairies, who they're awfully nice, and they occasionally provide free yogurt. I like that. That's good stuff, that is. Right. But anyway, I'm a film fan, so I don't have an agenda so much as a program of events. I'm going with who, what, where, when, why, how, these slightly inaccurately named 6 Ws. Okay. First off, who is functional programming? So I'll show you 3 gentlemen from history who were significant to the development of functional programming. One of these guys is a software developer. See if you can guess which one. This gentleman here is Alonzo Church. He invented a whole load of stuff that I'm not clever enough to understand, but the important bit's down the bottom here. This is a way of shorthanding a function into a little thing with an arrow on, which we do in C#, and particularly of note is this guy here. This is the Greek letter lambda, used to indicate a parameter, which is where we get lambda expressions. It's from this guy. This is Haskell Curry, after whom no fewer than 3 programming languages are named. Amongst other things, he invented currying, which I'll kind of get into in a bit later. He invented an awful lot of the ideas which are then later incorporated into functional programming. Could this guy be a software developer? He is. This is John McCarthy. He arguably invented the very first functional programming language in the 1960s. That's it on the side. Lisp, something like list processing language or something of that sort. I'm told it still has its fans to this day. Personally, never used it. Apparently, it's pretty wild and you can do some extraordinary things with it. Fine. But, so what is functional programming not? For a start, the whole point of the last few slides was to show that functional programming is not new. It's really quite old. In fact, the very beginnings of functional programming go back to the late 1800s. Sure, it wasn't computers in those days, it was maths. I once wasted most of a Sunday tracking down those old maths papers and realizing that I'm not clever enough to read any of them. But they do exist. And all of this stuff carried on into, all the way through the 50s, and then finally in the 60s is where it breaks into the computing world. But my point is, it's not like the latest trendy JavaScript framework. It is not a thing that is here today and so much fish and chip paper tomorrow, as they say in the UK. It has been around for a long time. It will be around for a long time. It is not a language. It's a paradigm. So what's a paradigm? If you want a metaphor, if a programming language is a guitar, then a paradigm is the style of music I play. I could play rock music, I could play jazz, I could play country if I have no soul, whatever. You get the idea. There are different styles of programming, and functional is one of them. It is not imperative. Now, that's the other dominant paradigm. By with the other, I mean it is the dominant paradigm. Object-orientated is a form of imperative. One of the big things that defines imperative is that you are very concerned with how things are done and modifying state piece by piece, building things up, and being very particular about the order of operations, how things are done, when, etc. As I'll get to in a minute, in functional, we're less concerned with this. It's not the solution to all of your problems. It will not heat the coffee in the morning, but it'll do a lot of other fun things. And it's not difficult. This is a common myth about functional, that it's difficult. It's not. In fact, there are fewer things to learn than there are for object-oriented programming. A lot of the folks that I know that have been the most enthusiastic about taking it up are often university students who learned it first, before object-oriented. The folks I know that tend to resist it the most are the ones who've been doing object-oriented for a very long time and don't really want to take on a new way of thinking, which is fine. So what is it? What actually is it? Okay, it's declarative. Now, this is the alternative to imperative. What is declarative? Well, you've probably done bits and pieces of it before. TSQL is declarative. This is where you are less concerned with the precise details of how you build up your object piece by piece. When you are writing TSQL, you write a select, a where, an order by, a grouping, etc. Do you care which order they execute in? I do not. It's not the order it's written in. If anyone's ever really dug into TSQL, it's not. The select is the last bit, pretty much. Maybe-ish, sort of. But honestly, who cares? And that's one of the defining features of a declarative programming language. You don't really care about the order of execution. You don't care about the detail of how this is built up. You declare what you want and then let it get on with it. Immutable. So immutable means once a variable has been set, you can't change it again, not ever. Can we do this in C#? I'll get to that in a bit. Sort of meh. We'll get to that. Higher order functions, funky, scary name for a simple idea that most of us have been doing for years. Functions passed around as variables. Done. There we go. Why do people love to come up with scary names for this stuff? I do not know. But there you go. Functions passed around as variables. We've been doing it since, what, C# 3? Function, not statement. So what's a statement? A statement's something that changes the order of the flow. If, where, for, all that stuff. Those are statements. Generally speaking, don't use them in functional. So try and imagine a program without those statements, and you're somewhere close, but probably confused if you don't know what we're going to do. We'll get to it. We'll get to it. Bear in mind. And referential transparency. Once again, slightly scary name for something quite simple. Also known as pure functions. So these are functions that are not allowed to rely on anything except their own parameters. Okay. The reason for that being, amongst other things, it makes them more stable, but also incredibly, incredibly testable. The whole point is that given the same parameters in, you will always get the same answer out, no matter what. No matter the state of anything in the system, no matter the whole life of the universe, no matter what, same variables in, same answer out. That's why it's called referential transparency. You can kind of swap the reference, but yeah, anyway, it's what it's called. Right, recursion. Are we all good with recursion? I'm guessing we're all good with recursion. Yeah. Going to be tough for you 1 or 2 bit later if it's not. Pattern matching. There was a time when I actually needed to go into a great deal of detail about this, but we're now doing it in C#, like full on, since about C# 8. It's basically switch statements with knobs on. Yeah, I've actually taken a load of slides out because of the way things have moved these days. Stateless, there is no state in a proper functional language. There's other systems. If anyone's used React, you probably have an idea of how we're going to go about doing that. And monads. Monads. That's the one that everyone gets all a bit concerned about when you start talking about. Well, I once saw a talk by Douglas Crockford, which was actually about JavaScript. But he said that the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. So I shan't. And it's not difficult. I hope in about 40 minutes or so you'll agree with me, but who knows? So where is it? My throat is getting dry. So where is it? Well, there's the functional languages. There are pure functional languages out there. There's a whole load of them. Haskell, Erlang. See, I told you, Haskell, there he is. There's one. He does have them named after him. They exist. I know they have their fans. I've heard Haskell gets used a lot in banking. Erlang, I've heard of uses of them. If anyone's ever used RabbitMQ, that's written in a pure functional language. So they exist, they're out there. I've never used them personally, but fair play to those guys that do. Hybrid languages, Java. I think Java, as often is the case, was the first to jump onto this particular boat. Java, C#, they support Python. These days you can do it in C++ as well. You name it, pretty much. An awful lot of languages support both paradigms. I should probably mention F# at this point. Yes, there is a .NET language, which is pure. It's not purely functional, but it's way more over to the functional side than C# is. Way more, and it's cool. I've never worked in it personally. If anyone wants to go ahead and do it, go for it, do it. It compiles to the same .NET runtime behind the scenes, so it is entirely cross-compatible with C#, with VB.NET. Now, at some point in one of these talks, somebody usually asks me, well, why don't we just use F#? Okay, here's my answer. Hands up if you know C#. Hands up if you know F#. There is my answer. That's a little facetious, but my point being, not that F# not well cool, it is well cool. It is not that F# cannot do everything, it can do everything. It's more that in a professional environment where you've got a team, you've got to keep your team full of people and so on, it is a much bigger and a more complicated investment to decide we're going to commit to F# than to C#, because C# developers are to a penny. and F# is a much rarer skill. But to be honest, if my boss said tomorrow, we've heard about F#, we want to go for it, I'd be on board. I'd be there for it. I would do it. The little bit of tinkering I've done with F# made it look awesome, but I don't personally know how to do it. So anyway, that's why this is functional C#. JavaScript, yes, JavaScript. JavaScript, the Wild West of programming. JavaScript supports everything and nothing, because everything is everything else, but also nothing, but also a function, but also an empty array, but also text. Possibly, except when it isn't, because JavaScript. So yeah. Okay, when is it? When is it good? Okay, it is good at anything. You can do anything with it. But when I say when, what I mean is these are the things where it's happiest. It is a paradigm based around predictability on the same things resulting from the same inputs. So these are the places where you tend to get your best results. Data processing. Chunk this data to this data. Great at that. Concurrent systems, yeah, because there is no state. There is no state, therefore it much better supports the idea of having a whole load of parallel processes going off. There's no shared state because there is no state. So I'm not saying that you don't get race conditions, because I'm sure it's always possible in any complex system, but you don't tend to get the problems of resource contention you might get in other languages. And criticality. Functional programs are more robust than object-orientated. You tend to get applications that will go up and generally never come down. There are pure functional languages out there which say, and I've got no reason to doubt them, that once these things actually stand up, you can't kill them short of pressing the power button on the server. And that is probably true. Now, C# can't probably ever quite claim that far, but they are more robust. So if you need this thing to go up and stay up, this may be the talk for you. And serverless, again, parallel processing. Stateless. If you're interested in going to the serverless route, this will support it strongly. So when is it not? Again, not that it can't do these things, but this is where it's less good. And this is things where you've got impurity sneaking in. And particularly things like external interactions, UI, there is nothing more impure than a human being. So this is where compromises have to be made. Now, I like to think of the metaphor of a shadow. A shadow has, well, broadly speaking, two parts. Yes, I know there's about 14 if you look it up, but there's broadly two. There's the umbra, the big dark bit in the middle, and then the penumbra, the sort of grey fuzzy bit around the outside. So if you want to, my goal when I am writing functional C# is to maximize the purely functional bit, that is the umbra, the dark bit, and minimize the sort of fringy bits around the outside where we've actually got to accept that there is a real world that we need to interact with. So that's kind of like a caveat. So why? I've touched on some of these. It is concise. That's not a small thing. How much of our lives do we spend looking at code and wondering, what does this do? You know, I support code bases that are upwards of 20 years old. I've seen one or two that aren't even that old, and really, how did they get into that state? I will never know, but it happens. Functional tends to be more concise, tends to be easier to write, and the patterns that we follow in functional tend to be such that it discourages some of the poor coding that I've seen in some of the code bases I've worked on. It is readable, it is testable, and this for some people is the one. This is one of the features for a lot of people. It is incredibly testable and predictable, and that's a great thing. And it was concurrency touched on that, robust touched on that, and it's fun. I think it's fun. I think it's fun, if no other reason that I'm incredibly lazy. And what I really love is not spending an awful lot of time doing code that I don't need to write. And this bypasses a whole load of boilerplate that I can't be bothered to write. So let's get on with it. Bit of functional code. How do we do it? This is not functional code. This is a bit of good old-fashioned object-orientated. This is the same sort of thing I have to stare at every day. The sort of thing that probably a few of us could guess what it does in a few moments, but junior developers might have to stare at it for a while. It's like looping, it's splitting, it's adding things to a list. And how would this look functionally? Well, you get a hint there because you can see ReSharper's already trying to tell me. Look like that. So if anyone's about to say, that looks like a whole big pile of Linq, that's a whole big pile of Linq. And not everyone realizes this, but Linq is functional. Linq is entirely based in the functional paradigm. When you write a Linq expression, you are passing in an arrow function, which of course is a function. It's a function passed around as a parameter. That's a higher order function. When you perform a select on an array, it's not modifying the original array. It is creating a copy of it based on the old one. So the old array is immutable. It's functional. And it's been around since what, C#4? Granted, there was a little bit of a gap before we got many more functional features after that, but Linq was the start. Linq is the beginning of C# supporting both paradigms. So my goal, in a way, is to turn the whole of C# into something that looks rather like Linq. So if, like me, you think that Linq's one of the best features of C#, which I honestly think it is, then hopefully you're going to enjoy the rest of the talk. But there we go. That's simple. And the nice thing is, easy to read. There's a logical order of operations. It's easy to throw something in, take something out. It's simpler to know what it's doing. And it's not, yeah, I like it. I think it's more elegant. And try adding a whole bunch of extra ridiculous logic into that. You can't. It's a Linq thing, see? Right, anyway, moving on. This is something that when I used to work for the tax people in the UK, I had to look for an awful lot. This is a validation for a NINO. Anyone know what a NINO is? It's less likely to be something people know over here. It's a national insurance number. It's like a code that you have to give in when you're paying your tax. It has a whole load of ridiculous validation logic. And what I've got here is a great big, long function. There's a whole load of early returns. I don't know if anyone can see that. Here we go. Checking each rule. If the rule's not followed, return false early. And then finally at the bottom, which is missing for some reason, there's a return true. Just trust me, it's there. So how would I turn this into something that looks vaguely functional? Like this, actually. So this is putting funcs into an array, which you can totally do. And once you start doing things like that, you can do some interesting stuff. Can everyone see my code, by the way? Not used to such a big room. Right. So I'll try and describe what we've got here. We've got a series of functions up here. I've described them separately there, just for the sake of readability for my code base. I've got one that says must have a length of 9, which is x, going to x.length is 9. This is must start with an alphanumeric, and I've got a regex. The rest are various other regexes. It's not really that important what these are. But here I'm sticking them all literally just into an array. And then here I'm calling .all. Now that's a Linq expression, so we haven't really done a very great deal to C# at the moment, but that is .all. So, and inside the .all, what I'm saying is take the original NINO, that is national insurance number, and then feed it into whatever x is. Now x in this case now is a function. All of these functions are strings to bools. Each one's about, so what does this mean? What this means is it's going to go through each one of these in turn, execute, and all means that every single one must return true. If a single one returns false, the entire all statement fails out. So all of that ridiculous boilerplate on the previous slide is now captured in the structure of this all. And that's so much easier. You could also do it like this. You could write an extension method. I am actually quite a fan of extension methods. They get a big rap, a bad rap. I don't think that's entirely fair. Just don't put any business logic in them. That's the way of doom. But other than that, extension methods are awesome. And so I've created myself a little extension method which takes everything and takes the list of predicates, that being things that turn whatever into a bool, and then runs them all. So that means I've now got a validate function hanging off almost everything. And I could just call validate and then list all of my validate rules. Wow. Imagine writing that longhand. Take it ages. This is another kind of example of how you'd use higher order functions. This isn't, we call this alt, or you could call this, I've seen this called a few things, but alt is as good as any. So in this case, I've got two funcs. They wouldn't really be funcs in the real world. Imagine they're database operations or text-based file lookups, whatever, I don't really mind. But the point is that this one here, number one, works. You're given a string and it will give you back a this works plus whatever you just said. The second one here is this doesn't work and it's returning a null. So the point is I've got two ways of looking up a bit of data. As I say, this could represent maybe a web API and maybe a file-based alternative. And one of them works and one of them fails. Okay. And in an alt scenario, what you do is input, which is my name as it happens, called .alt, and then pass it the two different methods. And what it'll do is try the first one, then try the other one. And this will actually work. So I'm passing in both operations, the first one that doesn't work first, and it doesn't fail. It will not break. It will not return null. That's how you do it. So first off, my alt, which is an alt of input, t input to t output, attaching to t input, which means it attaches to everything, and taking two funcs, your one and your two, which turn input to output. And I've created another extension called if default do, which just says attach to everything again, check whether it's null, and if it's null, do the other thing I'm passing in, which is the other function. Now, this here is the long, slightly scary way of actually checking null when you're dealing with generics, because not everything defaults to null. Integers don't, booleans don't, you know the song. Okay. And the last one of these, this is a fork. So a fork is based on the idea that you have a single input, then you have many prongs of your fork, each of which do a separate operation, and then you have something at the end which sticks all the prongs back together again. So this is a ridiculous example, and why would you ever do this? But I'm just demonstrating. So I've got this great big long string. It's actually based on one of the exercises from the Advent of Code. Did anyone do that? I love the Advent of Code. That is my December burnout that I go through every year at about the 13th of December. That's usually about as far as I get, at which point it's either collapse in a nervous wreck on the floor because of how much I'm working, or stop doing the Advent of Code now. But anyway, so what I'm saying is here, this is pass in your function, which is going to stick everything together, which is a sum in my case. And then each prong is going to count a different item, and A's, B's, and C's. And again, why would I ever do this in the real world? But my point is, you can go one input, many calculations, then stick them together again. Again, it's a sort of, we're separating out the structure of the code from what you actually, the specifics of what you're passing into it. And that's how you do it. It's just the same sort of thing again. We've got our funcs. We are, this is map. This is one of those great tools you never really noticed you needed. It's just a simple extension method which attaches to everything and takes a func that turns old thing to new thing. What it means is you can kind of like do a select, except it selects the whole object at one time. Instead of selecting each element of an array, it's the whole object. So I find it very useful. And then the fork is just take the join and then a param, so you can stick as many prongs as you like, each of which is a func. So these are the sorts of fun things you can do when you start playing around with the idea of higher order functions, that is, functions passed around as parameters. So moving on to a different area. This is one of those examples that you get in an awful lot of object-orientated books. This is bank accounts. So I'm going to imagine that there's a standard bank account, which has got a balance and an interest. We'll inherit on that with the super duper one, which has got a bonus interest. And then after that, the dodgy one, which has got a brown paper bag of money, presumably passed in a car park. Now, insert the name of a politician you don't care for at this point. I'm not going to name a name. I know I'm thinking of one. But you feel free. Knock yourself out. So I'll have different rules for each of these bank accounts. Now, this was one of the bits that when I started doing this talk was quite revolutionary, but these days it's becoming a little more normal. So there we go. Switch statements in not the very latest C#, but there's the early version, which is still really well cool. And this is switching on type. So if anyone hasn't seen this, go play with it. You're switching here on the type, not on the values within it. So I'm passing in a base bank account. I can switch on whether it's actually a dodgy bank account and then wrap it into a local variable here. So that means that if it really is one of those subtypes, it will hit this case and then it will be wrapped into this local object. So I could bypass all of that tedious checking with if type double equals and then doing some switching of types and all that sort of thing. Does it all for us. There's a lot of boilerplate now. We just don't need to write anymore. And you can also stick in a when to be specific about the properties of the class. Now, as of the very more recent versions of C#, it looks actually more like this, which is even cooler. And one of my favorite features since the most recent cool features. And it's a much nicer syntax. We're bordering on something that looks a lot like JSON now. And this is also incredibly cool. This is a default over here, the underscore. Now, as of C# 11, which isn't out yet, it looks like they're planning to enhance this sort of feature even further. So there's talk of pattern matchings which match on the elements of arrays, which sounds brilliant. So things like switch on this array is empty, or switch on this array starts with this element and then ends in this element. That sort of stuff sounds well cool. And I could imagine that might be useful for dealing with things like serialized data files and stuff like that. But as far as I'm aware, it's not all finalized, and C# 11 comes out at the end of the year, I think. So watch this space for an update to these slides again at some point. Mutability. So we talked about immutability. Can you do immutability in C#? like I said, the short answer is meh. The long answer is this. So this is immutable. It is. These are an int and a string. I have got a getter. I have no setter. I am setting them within the constructor. So sure, this is immutable. No worries. Is this immutable? So I have now added an iList here, type C. Now it's still got no setter. Is it immutable? No. No, it's not. Because I can still call the .add. So it's not. I could change it like this. There we go. Mutable array. There we go. Sorted. It's immutable now. That's fine. You can pass in as many lists as you like. You can't change it. So we're good. How about this? I've now got a subclass. I don't know what subclass is. I've called it subclass because I don't care. Is this immutable? Well, actually, I don't know. I don't know. Does subclass actually implement immutability? I don't know. And this gets even more complicated when you start dealing with things like third-party libraries, stuff that is well outside of your control. So, frankly, it's a little bit of a pipe dream, immutability in C#. I mean, yes, we have this feature, which is you can stick nullable at the tag at the top of your file, and it won't actually make things immutable. It'll just put a compiler warning here if you try to make things null. So there's that, I suppose. You get stuff like that, and it might look like this. It might give you warnings if you try to put null into statements like this. It'll give you a compiler warning and warn you you're about to make something null. That's good. It's not terrible. It's not immutability though. Yeah, you can also put in where is it? Ah, there we go. You put exclamation mark in there as which is a flag to say I'm a grown-up. No, I really do want to make it null because I don't know why you'd want to do that, but you do. You can set it globally like this, which again is mostly dealing with the problems of nullability, not the same as immutability. So this is a good feature. There you go. This is probably about one of the closer ways we can get to it. That is using init properties. Yes, it's still not really immutable because I just don't think we can do it. Not really. Basically, my approach is to pretend. Just basically pretend that immutability exists and act like it does, but it doesn't. I mean, fundamentally, C# is not a pure functional language. It never will be. That is not on the cards. And for backwards compatibility reasons, I don't think they're ever going to implement true immutability. It's just not going to happen. If it means a lot to you, shift to F#. That will solve your problems. F#, sure, it's immutable there. But C#, I don't think it's ever going to be. But you could still behave like it is. Nothing stopping you. So this is another feature which has come in C# just recently, and this is my most favorite feature since the other features. This is a record type. Has anybody played with record types? They are pure awesome on toast, aren't they? I love them. The whole idea of a record type is that, amongst other things, you can create a new record. So record, when I say record, think class. They're pretty much the same thing as classes-ish, except they have one amazing feature, and that is I can create a new one from the old one with one change. That's well cool. It makes it an awful lot easier to pretend really hard that immutability actually exists, because I could do stuff like this. So I'm doing a switch statement on, this is a totally made-up example where I've got a person class, and I'm saying that there is an update operation, enum, which is telling me the different kinds of update I can do. This is totally made up, but it's just to demonstrate. And I'm saying if it's a first name, then here we go, p with first name equals whatever. So my param here, which is a string, could equal any of the fields to be updated, but the with statement is the thing that says, take a copy of the old person, return a new person, which is identical, except with the changes I just said. That is one of the most boilerplate saving changes that have been in C# for absolutely ages, and it makes it very, very easy to implement something close to proper immutability, because that's generally the way I do it. When instead of going for this sort of object-orientated method of passing my class by reference, change it inside, which I do not like, it makes me feel squeamish. Instead, I tend to make a replica of the old one and then return the new one. And this makes it incredibly simple to do that. So record types, check them out if you haven't already. They are smashing. So I did say I'd talk about currying. Here we go. So what is currying? We're about to find out if anyone in the audience knows. This is a hypothetical add function, A plus B. There we go, nothing controversial there. If this was an actual curried function, so, well, if it was non-curried function, I could give it 10 and 20, and I'd get 30. No worries there. What if I were only to give it 10, and it was a curried function? Can anyone take a guess at what the heck I'd get back out of that? You'd get, yeah, a function. You'd get back a function. Now, there is a rule of thumb in functional programming. If there is a question, the answer's functions. It's mostly true. It's always more functions. That's why, by the way, it's called functional programming. It's not because the other stuff doesn't work, which arguably, but it's not. It's because it's all based on functions like Lego bricks, all sort of piled on top of each other. So yeah, if you passed in a 10 to a curried add function with 2 parameters, what you get back is an add 10 function. So a function where the 1 parameter has been filled in. So can we do that in C#? Sorta. Bit. You could do it like this. This is one method. So I do this sometimes. I don't know if it's quite clear, but we've got 2 arrows. Arrow 1, arrow 2. And what this is an add, a subtract, a multiply, a divide. So these are your basic mathematical operations. What I've got basically is like a factory which produces more functions. That's kind of close to currying in principle, but it means you literally have to apply the parameters in order, one at a time. You know, it's not perfect, but so what it means is if you call this thing this add, you give it 10 here, what you're actually getting back is this, x plus y, where the x has already been filled in. You can do that. And sometimes I do it for the sake of, if nothing else, occasionally it looks a little bit more descriptive than sticking in long arrow expressions. There are other ways. So this is what's called an example of how you might do a partial application, it's called, which is where you fill in, say, 2 or more parameters at the same time. You can do it like this. So this is a list of Doctor Who stories. Now, I don't know if Doctor Who's well known over here in Portugal, but it is the best TV series in the entire world. It actually is. If you look in the dictionary, you'll find it right there with a big picture of the TARDIS and everything. I'll fight you if you say otherwise, I'll fight you. So this is a list of the very first series episodes from 1963, starring the boss, William Hartnell. And we've got it in CSV format. I've got the serial number of the episode. It's the title of the episode and how many episodes it was comprised of. Okay, and here I've got a great big long parser, and it's got 4 parameters. I've got take the thing, the actual string, the whole string is 1 parameter. What do I split the lines by, which is new line in my case? What do I split the fields by, which is commas in my case? And so on. So you fill all 4 of those parameters out and what you get back. And then finally, which bit of data of this array I'm actually interested in. You fill all those in and basically you like get an list of the episodes or something. But wouldn't it be neat if I didn't have to write a different one of these for wanting to do a summary of each different column of data? Well, you can with a partial application, which sadly looks absolutely horrendous, and I'll show you it in a minute. But here's how you might use one. So up here, we've got our array. So then I'll do dot apply, which is how I might do my partial application to fill in some of the parameters. So what I've applied here is the new line being the thing I split the lines by, and the comma, which is what I split the fields by. So what I've now created is a parser function, which feed it any CSV, it'll split by line and comma, and you get back an array of arrays. And I can reuse that as many times as I like. Then I could apply with an additional parameter to say I'm interested in the 0th field out of this list of stuff you got. So now what I've got is a function which, give it a big long CSV, you get back a list of all the serial codes. And here I could call it again and pass in a 1 to say I'm interested in the number 1 field to get back a list of the episode titles. What it means in short is I wrote 1 parser function by partially applying bits at a time, I can create a sort of tree of a whole load of functions, all of which do all sorts of things in a sort of inheritance-like scenario, but I still only write one function. It's a way of reusing code to a ridiculous extent. It's really cool. It can be done. But it's hideous. Like hideous. That's what it looks like. So it totally can be done. And what basically I'm doing is taking a func as a parameter and returning a different func, filling in. What this also means is because we're not all that fluid in C# with how many parameters in to how many parameters out, for every single combination of how many parameters in to how many out, I've got to write another one of these. So you could basically write a novel length code file to make it happen. You can, all power to you if you want to do it, but yeah, it looks a bit hideous. So, a functional flow, a sort of standard functional flow. We start with one thing, split it into many things, filter it a bit, turn it into something else, and then the final bit. The final bit is aggregation. Now, there was a time when I thought surely this is not terribly controversial or terribly unknown, but it astonishes me how many people don't realize you can do this sort of stuff quite easily in C#, turning many things into one thing. It's actually really ridiculously easy in C#. There we go. This is how I see most people doing it. This is a string builder, which is looping through my Doctor Who stories and like preparing a list, adding a comma. We've got an if statement there to make sure that you don't end up with a comma after the very last item, because that looks kind of funny. And what we should end up with is like a list of all the stories with a comma, except the last one, and a new line in between them. Or you could do string.join. I mean, yeah, I love string.join. But how come nobody knows about it? I don't understand. But anyway, that's string.join. That's a slightly easy example. What if I want to do something more complicated? This is my hypothetical list of Doctor Who stories. So I've got the serial number, I've got the title, I've got the rating, I've got the number of episodes, because in the old days, each story was many episodes, and how many are missing. Now, sad story, there are 97 episodes of Doctor Who that are missing. If any of you happen to have them, please, please, please hand them back, because I'd like to see them again, please, especially if it's Fury from the Deep. That one's cool. Anyway, what if I wanted to create a report, which was some sort of percentage-based thing based on the number of episodes existing to not for the stories? And you could totally do that in all sorts of ways. We can do a sum. A sum is just how you get the number of episodes. That's, again, Linq. Sum there. But then there's averages. If you want to get average ratings, that's the easy stuff, still fairly standard Linq. There's the more complicated version. And again, I am astonished by how many people don't know about this. Aggregate. This is the grown-ups version of all the rest of that. So this is where you're not just going with a simple sum, a simple average, or whatever. You're specifying your own entirely different behavior. I use this flipping tons. And this is, again, based in the functional paradigm. I think it actually uses recursion behind the surface. And what you do is set a seed value. Your seed value is what you're starting with. Now, in my case, I'm using tuples. Tuples is how many total are missing to how many total overall of episodes. And then inside that, you provide another function which says, based on the current item, that being like your X in a select, and the running total, that being what I processed so far, what is the new running total? So given this episode, the new number of total missing episodes is equal to whatever the old total was plus the new episodes set. And again, over here. And then we end up with from an array of data about missing Doctor Who stories, we end up with a single value with all of the values summed in a nice, handy, easy form. Now, this is a silly, simple example, but I have put some very complicated logic into some of these in the past for preparing reports and for getting final values out of things. I recently put together an application for work for COVID-19 data, and we used aggregate quite a lot in that because it's so much easier, simple and quick and fast to write compared to the alternatives. So, one of my last sections, I'm going to talk about how we're doing for time. Not too bad. Right. I used to work for an American company, and there is a bit of a cliche about British people, and that is that we like to talk about the weather. It is true, we do. We talk about the weather all the time, partly because we have never a clue what the weather is going to be an hour from now. That's roughly how it works in the UK. So there is a saying that you can get 4 seasons in a single day, and it's probably true. So my American colleagues would say things like, and I'm not going to do the accent, I can't, but they would say things like, it's 100 degrees outside. Now I think 100 degrees, that is the boiling point of water. How are you still alive? No. They mean Fahrenheit. Oh. Fahrenheit, that thing I don't understand. Great. How do I convert it? Well, what is the conversion for Fahrenheit to Celsius? It is deduct 32, multiply by 5, divide by 9. Of course it is. Simple. But here I have my little converter function. I'll do each of those operations, one after the other. And I'll do a math.round, so I've got a more sensible figure. And then finally, I can put it into a string, put degree centigrade. It looks pretty good now. That's fine. Nothing wrong with that. There are better ways of writing this, though. There's a more functional way of writing this. This is something called an identity. It's a thing in a box. Thing in a box. Thing in a box. What's in the box? Spoiler. So, what is this? So, identity of T, meaning T is anything. It could be whatever. Like I said, thing in a box. And that is how I get it. That's how I set it, because it's immutable, kind of. Bit of syntactic sugar, just to mean that I can easily pull it out the box without having to bother to call .value. Easy peasy. And I'll write in an extension method. The first one there is to just turn anything into an identity. And then the second one here is called bind. I've seen this called all manner of things. I've heard it called map. I've heard it called all sorts. I don't really care what it's called. But the point is, this is like a select. It's like a select in Linq, except, once again, it operates on the whole object. Okay, you could use bind on an integer, and then this is saying, your arrow statement is saying, turn the old integer into something else. There are two generic parameters, so old type to new type. I can quite happily shift from a string to an int to a string, provided whatever is inside this func does that transformation. I don't care. But if you fed it an enumerable, you will see the whole enumerable at once, because it operates on the whole object. And that's all that is. And that's what that looks like. Oh, and the other thing is, it takes the value out of the old identity and then returns a new one. So basically, take it out of this box, do a thing, put it in this box, and then send it on its way. That's what it does. And that's what it looks like. So I'll take my decimal input, convert it into an identity, bind, subtract 32. See, there we go, currying. I told you I use it. Subtract 32, multiply by 5, divide by 9, math.round, way, done. And all of those transformations are stored in this. There are none of those modifications of state. I don't have to create a little local variable that I literally use once and chuck away, which isn't a small thing, because I have seen functions that stretch over thousands of lines of code, and things defined up the top, still in scope at the bottom. So we've got a great big object defined up here, still in scope down here. If you do it like this, when you run that bind and you run this multiply function, the moment that this bind has run, out of scope, subject for garbage collection. So it's quite clean in that regard. You are actually getting automatic cleanup of your cluttered stack. So it's not a terrible thing. This is the simplest example. And by the way, the name for this structure is monad. So if anyone was ever curious, that's what they are. Thing in a box. It's kind of like a relay race. Think of it that way. It's a relay race. Your person is running around the track doing their thing, handing over the torch. Next person runs around the track. They might do a different thing. It's a funny relay race in that regard. Everyone runs a different track, but still, the principle is sound. That in and of itself is not actually terribly useful, really. But this is where we can add a level of complication, which will make it more apparent what this is bringing to you. Okay, this is another example. So I'm getting a person ID. I'm running this hypothetical function, which is getting a person. And then I'm calling a series of binds. So based on my person, I'll take their first name and their last name and their age. I'll replace A's with 4s, E's with 3s, I's with 1s, O's with 0s, because that is what we call leet speak. And that's because I'm cool, and that's the way I talk, because the kids still do leet speak, don't they? No? Yeah, because we're cool. Right. But here's a problem. What if my get person 2 there didn't find anybody? What if it returned null? What happens inside this bind? Explosion. Null reference exception. That doesn't happen in functional programming. And I'll show you why. So this isn't actually an identity like the last monad. This is a different one. This is called maybe. And this is the simplest useful monad that exists pretty much all the time, because it's tedious for me. Okay. A maybe there, and it's roughly the same as our identity. There's an abstract. This is an abstract now, not a class. It's an abstract. Now a bit about projection. Plus, I'm a big loudmouth. Am I on? Am I on? Oh, well, good. Right, sorry. Yes, Scott Vlashin. Very good website, by the way. It's actually an F# website, but there's a lot of very good stuff on it for all sorts of stuff, like the slightly more philosophical. Oh, yeah, there we go. That is loud, isn't it? Right. I was having so much fun, I didn't notice. Right. But the point is, imagine this, right? He calls it railway-orientated architecture. So imagine that you've got a railway running along, and you've got two tracks. You've got the happy track, the something track, and you've got the nothing track underneath it. And every now and then, you've got a set of points going along like this. And these points are your bind functions. And what it means is, at each point, the bind runs. It transforms the old thing to the new thing. But also, there's a check involved that says, did it work? Did it explode? Was there something coming out of this? If there was something, if we still got something, we move along again. And then we move on, and we move on. If at any point something failed or nothing came out, you switch. You switch to the nothing track. And if you're on the nothing track, you don't do any more work. You just glide along to the end. That's what that looks like. This is my modified bind function. Looks like this. So there's a switch statement in there, and I'm checking that whatever came out of this is always now a maybe, which I remember the maybe might be something or nothing. So I'm checking, was it a something? Was it null? And if it was not null or whatever, and it was a something, that means we've actually got something we can operate on, in which case I'll run the function. I'll run the function, grab the value, stick it in another maybe, send it on. All other circumstances result in a nothing coming out of this. Or I'll also put a try catch in there. So if we go back to our example, what this would mean is, so let's imagine that null comes out of this. So this is a maybe, this is a something, we've got an integer. This is a getPerson2. Now this is actually converting it to like a person object. But let's imagine that null comes out of it. Well, at this point, it's still a something. This will come out, and this is a something at this point. But it's a something with a null attached. This bind will say, check this. Is it a something? Yeah, it is. But it's got null in it. I'm not going to execute this function. So I'll just pass it along. I'll just pass the empty box on to the next guy. This one will do the same. Empty box, pass it on. Empty box, empty box, empty box. Imagine if I didn't do that. Imagine all the if statements I'd have to write. Imagine the length of code just to try and defend myself from nulls and null reference exceptions. All of that error checking is now contained in the structure of my code, and I don't need to bother to write it ever again. And goodness me, the amount of code extra I would have written if I didn't have this is phenomenal. This is one of the best code-saving tools I've ever come across. So I thoroughly recommend this. And then at the end of it, I would probably do a switch statement that just says, at the end, did I have something or nothing? And in fact, what I often do in my interfaces is, when it's, say, a database lookup, I will actually return something along the lines of task, maybe person data. Task because it's async, maybe because I don't know if it returned something or not. And what I'm saying by putting it in the interface is, I don't know if this worked. I'm giving you a container which might or might not contain something. Your alternative, which is what I tend to see people do, is you create your own custom return type, which has got object and a Boolean or something that says it worked or it didn't. This is doing all that for you. Don't need to do it again. It's a structure you can use. There's an, what's that one? Oh, yes, my maybe. Okay, there's another alternative, which is more actually close to what I really use in production. We call it an either. We've got a left and a right, same principle. Left is bad, right is good because of some sort of old tradition. And in the left, which is the one where it didn't work, I'll also capture an exception. So if at any point an exception occurred, I'll capture it in the monad. Even though there's a whole load more binds following it, I will still capture the last point where it worked. I'll capture the exception and the last state of whatever it was that was held there, and then I can log that, and we can know exactly how to recreate the problem. Easy peasy. And yeah, it's another slightly more complicated. Okay. Another question I ask a lot, and here's an answer. Are there any frameworks out there that already implement this stuff? Yes, there are. This is LanguageX. It does most of this stuff. That's what language, it's a little small, I apologize. I can put this up if anyone's interested. It looks very similar to what I just wrote. It's not quite the same. One difference is that they use map, not bind, and they force you at the end of the maps to give two different functions, which will force it to collapse into something at the end. And that's fine, that's fine. Personally, I quite like rolling my own, as it were, because if nothing else, it gets me used to the way to do all this. It's a nice insight into how this all works, what the system is, and it's not a lot of code, really. Usually, you write a teeny little bit of funky code, and then you can reuse it all over the place and do incredible things. So, but yeah, LanguageX, a lot of people like it. I don't use it. Further reading, places you can go. The best book on programming I've read in a very long time is called Functional Programming C#. It's by Enrico Buonanno. He has yet to reply to me ever on Twitter. But it's published by Manning, second edition now available. There is a book by Visno Angoro, published by Pact. It's okay. It's not quite as good as the Buonanno book, but it's there. It's whatever you want it. The actual first time I was ever exposed to functional programming was at NDC Oslo. It was a talk by Kathleen Dollard. Called Functional C#, and that was the first time I'd been introduced to the idea of functional, and my journey has been continuing ever since. There are talks on Pluralsight. There's Scott Vlashin's website, which is absolutely worth checking out. Even if you're never going to pick up F#, it is still worth browsing. Now, small announcement, which I think is something of an exclusive for you folks. I'm writing a book. That's it. That's my book. It's not actually the final cover. I'm writing this for O'Reilly. It's going to be called Functional Programming with C#, written by me. If anybody wants to scan this is a discount code that'll get you a 30-day trial with O'Reilly's learning platform. I can stick this back up if you want to have a look at it again later. Feel free, dig in. They gave me this. It's all legit. So this is currently available in pre-release right now on the O'Reilly website. There are currently 2 chapters and the prelude made available to the public. No spoilers. The butler did not do it. But roughly the plan is to release about a chapter a month up until around December, and then we'll be getting somewhere close to actually releasing this thing in paper. So if you want a dead tree copy, that'll be next year. But anyway, I am writing a book. But in the absence of that, there are plenty of other good books. But, I wrote this one. Any questions? Any questions at this point? That's not my baby, by the way. Sir? I'm sorry, my hearing's not very good. That's my fault. One-off?
One-off, yes.
Okay.
It's kind of a maybe kind of library, does kind of the same sort of stuff. I was just wondering if you tried that out in this kind of context.
Okay, no, I have never heard of it, I'm afraid. I'll certainly have a look at it. As I said, my tendency is the maybe concept is so simple, I just make my own. And the nice thing there is I can customize it to be whatever I want. I tend to hang like little extra on events hanging off it. So I'll write my long stream of maybe, bind, and I'll do like on error and on success and stuff at the end. So I like to write my own functionality. So no, I haven't. I'm sure it's worth checking out, but I've never seen it. But no, what did you say it was called again?
One-of.
One-off. I will check it out. Thank you.
I think one of the things about it is also like there's some code generation underneath. Okay. I was wondering like kind of a performance in this context.
That's a good question.
Is that thing you, yeah.
Okay, performance. Yeah, that's a fair question. This is probably not, the sort of code I've shown you is probably not optimal. Is that a problem? Generally, no. The reason being, it is an awful lot easier for me to write my lovely code that's easy to maintain and then just chuck a whole bucket of CPU and RAM at it than it is for me to write optimal code. So I've seen, I know there are books on high performance C#, but generally the more optimal your code gets, the less readable it gets. So it is true that you could probably write more optimal code, but unless you're working like mobile apps or somewhere where performance is 100% the focus of your business, and I know places there are places like that, then I don't honestly really care. Like, it is the furthest thing. My main concern is, can I really maintain this quickly and easily and get the business requirement out the door fast? And I'd say this supports that, but I would say performance-wise, it's not horrible. It's not terrible. There's nothing wrong with it. My COVID-19 app, that got hit by one of the highest rates of traffic in the whole history of the business not long ago. Wrote it entirely functionally. It was fine. It was fine. So it's okay. It's fine. Not optimal maybe, but it's fine. If that answers your question, sir.
Yeah, it does. Thanks.
No problem. Does anyone else have any more questions? Sir?
Do you have any tips on implementing functional programming in existing code bases that aren't functional?
Okay, the question was, do I have any tips for implementing functional programming in existing code bases? Prayer. No. To be honest, I would just do it a bit at a time. Most of the techniques I've shown, for the most part, with the odd exception, things like pattern matching, those will work on nearly any version of C# going back to about C# 4. So I just put in a bit at a time and a bit at a time and a bit at a time. The maybe thing, I would stick that in a code file at the back of your code base somewhere you don't really care about it. That is like the hypothetical snarf from Thundercat's action figure that you own, don't want to admit to, but it's kind of there in a box. And then shove that at the back and then just start using it. I wouldn't go and plunder the whole code base and modify the whole thing. I just, whenever you make a change, you do it this way. Or if you see a quick win, do it this way. Maybe you've written a new function, make it a maybe, the return time, and start doing it in a monadical. Is that a word? I think I just invented that word. If you see what I mean. Bit by bit, by bit, by bit. If nothing else, it gets the rest of your team used to it. So rather than bing bang, change everything, which is probably just going to annoy everyone. Any further questions? No? Going once? Going twice? Well, I declare this meeting of the Midnight Society in order. Thank you. Yeah. That's my Twitter account, by the way. Feel free if anyone wants it.